Let's learn in this video an interesting set of questions which we call grouping. Over here I have a sample question. In how many ways can you distribute 15 identical chocolates to 4 children? Alright, let's say that these are the 4 children to whom we have to give the 15 identical chocolates. Alright, so there could be different answers to this, right? For example, I could give 4, 4, 3 and 4 to these 4 children. So that adds up to 15, right? Or I could give 2, 1, 1 and 11. This also adds up to 15, etc. So there are many solutions to this question. Now, another way of writing the same question is w plus x plus y plus z is equal to 15. Find the number of whole number solutions, right? These two are one and the same question. Remember, whole numbers are the numbers that start from 0. That is 0, 1, 2, etc. are whole numbers. Over here also you could have a case where you give 0 chocolates to this guy, 0 to this guy, 0 to this guy, and all the 15 go to this guy. This also adds up to 15, right? Now, instead of the 4 children over here, I could have 4 variables also. And the only thing is that when you add the values of the 4 variables, you should get 15. Therefore, these two are one and the same question. Now, let's see how we can attempt very quickly these type of questions. We have seen that w plus x plus y plus z is equal to 15, and finding whole number solutions is the same as the case where we distribute the chocolates to the 4 children. Alright, over here we have 15, right? Let me represent this 15 over here as 15 dots. Alright, so these are my 15 dots and I need to divide them among 4 people or 4 variables, right? Now, to divide this 15, which I have represented over here in a diagram, into 4 sets, I just need to draw 3 lines, right? If I draw 3 lines anywhere, it divides it into 4 sets. Over here you have 3, you have 3 over here, and 6. Let me take another example. Over here again I redraw the 15 dots and I draw 3 lines like this. Now, over here the 15 items are divided into 4 sets as 0 over here, 6 over here, 1 over here and 8 over here. This also adds up to 15. Therefore, we just need to find the ways in which we can arrange 3 lines and 15 dots to find the number of whole number solutions of w plus x plus y plus z is equal to 15, right? Because every time I make a new arrangement of the 3 lines and 15 dots, I get one set of solution for this equation. Just like over here we got one set of solutions, that's 3, 3, 3, 6, and over here we got one set of solutions, that's 0, 6, 1 and 8. And over here we have a total of 18 items, 3 of which are of one type and 15 of which are of one type. Therefore, the number of possible arrangements of this is 18 factorial divided by 3 factorial into 15 factorial. And that is the solution of this question over here. This one over here. And you can notice that this is nothing but 18C3 as per formula. What is the expansion of 18C3? That's 18 factorial divided by 3 factorial into 18 minus 3 factorial, which is 15 factorial, which is one and the same that we got over here. Alright, therefore the solution to this question over here is 18C3. Let's quickly revise the part where we discussed how to arrange n things of which A are of one type and B are of one type. Say I have to form all the arrangements of this word over here. A, B, B, C, C, C. Alright, now the total number of letters are 1, 2, 3, 4, 5, 6 and 2 are of one type and 3 are of one type. Therefore, the possible arrangements of this is 6 factorial by 2 factorial into 3 factorial. That's the same thing that we have applied over here and we have got the answer as 18C3. Let's do a question. Find the number of whole number solutions for A plus B plus C is equal to 50. Pause the video, give it a try and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. This is nothing but drawing 50 dots and 2 lines, right? Because if I draw 2 lines, it divides the 50 dots into 3 sets, and that is one set for A, one set for B, and one set for C. Now I have a total of 52 items, right? 50 are of one type and 2 are of one type. Therefore, the number of arrangements possible is 52 factorial divided by 50 factorial into 2 factorial, and this is the same as 52C2, which is your answer. Now 52C2, we know we can solve it as 52 into 51 by 2, and when you solve this, you will get your answer as 1326. We have discussed these two questions so far, and we have seen that they are one and the same, right? Now let's discuss a few variations of this same question, which we will be discussing in greater detail in the following videos. A similar question could be, how many numbers less than 10,000 add up to 15, right? Over here, numbers less than 10,000 have a maximum of 4 digits, right? Because this is a 5-digit number, right? Therefore, let me represent the 4 digits over here, and they need to add up to 15. Therefore, this is one and the same as w plus x plus y plus z is equal to 15. The only difference is that you have an upper limit over here. That is, each of these being a digit, they cannot be greater than 9. So w, x, y and z have to be less than equal to 9, or in this question you have an upper limit. Alright, what another variation of this question could be, 4 dice are thrown. What is the probability to get the sum as 15, right? This is also w plus x plus y plus z is equal to 15, but there is an upper limit and a lower limit. That is, each of these has to be less than or equal to 6, because that's the maximum value you can get on a dice, and they have to be greater than equal to 1, because you cannot get 0 on a dice. Alright, let's see a few more question types which are similar to this question which we have discussed. Say I have a question that says w plus x plus y plus z less than or equal to 15, right? Over here we had equal to, over here you are getting less than or equal to 15. Over here also it's a similar question, and we are asked to find the whole number solutions. We'll see that also in a future video. And a similar question is grid based questions, where you have a grid and there is a person at point A and he has to go to point B, and he can only travel towards the right and towards the top. This question is also very much similar to these questions which we have solved, and we will discuss that in future videos. In this video, let's discuss grouping questions with a lower limit. We have an example question over here. W plus x plus y plus z is equal to 15, and we need to find whole number solutions, and w, x, y and z has to be greater than equal to 1. Let's try to analyze this question. It's given that w plus x plus y plus z is equal to 15, and each of these has to be greater than equal to 1. So the way to go ahead with this is, let's distribute 1 to each of these. So I give 1 over here, 1 over here, 1 over here and 1 over here. That's 1 plus 1 plus 1, which is equal to 4, right? Because I've given 1 to each of these 4 variables. Now 15 minus 4 gives me 11. So after distributing 1 to each of these, I am left with 11. Now I just need to follow the same process which we discussed in the previous question. That is, I have 11 dots, and because I have 4 people, I need to divide these into 4 sets. For that, I need to draw 3 lines. So I have a total of 11 plus 3, that's 14 items. 11 are of one type and 3 are of one type. So this can be arranged in 11 plus 3 factorial by 11 factorial into 3 factorial. That is 14 factorial by 11 factorial into 3 factorial. Now you can notice that over here, instead of writing whole numbers such that each of these is greater than equal to 1, in the question it could also have been mentioned that we just need to find natural numbers as solutions, because natural numbers are numbers that start from 1, that is 1, 2, etc. Alright, and if you are given this as the criteria, the solution is 14 factorial divided by 11 factorial into 3 factorial, and you can also note that this is equal to 14C3. Let's do a question. W plus X plus Y plus Z is equal to 15, and it is mentioned that W has to be greater than equal to 1, X has to be greater than equal to 2, Y has to be greater than equal to 3, and Z has to be greater than equal to 4. And we have to find integer solutions. Alright, now pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. It's given that W plus X plus Y plus Z has to be equal to 15. Now, because W has to be greater than equal to 1, X has to be greater than equal to 2, Y has to be greater than equal to 3, and Z has to be greater than equal to 4. So let me give 1, 2, 3 and 4 to these 4 variables. So 1 plus 2 plus 3 plus 4 is equal to 10. 15 minus 10 is equal to 5. So I'm left with 5, and I just need to follow the same process for these 5. That is, I have 5 dots, and because I need to divide it into 4 sets, I have 3 lines. So I have a total of 8 items. 5 are of one type and 3 are of one type. So this can be arranged in 8 factorial divided by 3 factorial into 5 factorial ways, which is one and the same as 8C3, which is your solution. Let's do one more question. Find the number of integral solutions for A plus B plus C is equal to 30, where A, B and C have to be greater than equal to minus 1. Pause the video, give it a try, and then we'll do it together. Alright, we are back. I hope you have given it a try. Let's do it together. It's mentioned that A plus B plus C is equal to 30, and each of these have to be greater than minus 1, right? Therefore, let's distribute minus 1 to the 3 variables. That gives minus 3 over here, and 30 minus 3 is equal to 33. Now, I just need to follow the same process for 33. That is, I have 33 dots, and because I need to divide it into 3 sets, I have to draw 2 lines. That's a total of 35 objects. 33 are of one type and 2 are of one type. This can be done in 35 factorial divided by 33 factorial into 2 factorial ways, which is the same as 35C2. And what is 35C2? That's 35 into 34 divided by 2, or 35 into 17. And this is your answer. In this video, let's discuss grouping questions with an upper limit. Over here we have a question, W plus X plus Y plus Z is equal to 15, and each of these has to be less than equal to 8. Now, if this condition over here, that is the upper limit, was not given, we know that the answer would be 18 factorial divided by 15 factorial into 3 factorial, right? Because you have 15 dots, and because you need 4 sets, you need 3 lines. That's a total of 18 objects. 15 are of one type and 3 are of one type. Let me write that. So if there was no upper limit, the answer would have been 18 factorial by 15 factorial into 3 factorial, which is 18C3. Now, to find the answer to this question where we have an upper limit, all we need to do is, from 18C3, we need to subtract the violations. That is, where this criteria over here, that each of these has to be less than or equal to 8, is violated. Now let's try to find the violations. It's given that W plus X plus Y plus Z is equal to 15. Now if I give W 9, that's a violation, right? Because the maximum value over here that is permitted is 8. Now after distributing 9 to W, I am left with 6. Let me keep that aside. Now these 6 I need to distribute it to W, X, Y and Z, and this I can do in 9 factorial by 6 factorial into 3 factorial ways, right? Because I have 6 dots and 3 lines, because I need to divide it into 4 sets. That's a total of 9 objects. Therefore 9 factorial, 6 are of one type and 3 are of one type. Therefore 9 factorial by 6 factorial into 3 factorial, which is 9C3. Now over here I got 9C3 by giving W9. Similarly, I could have given X9, or I could have given Y9 or Z9. Therefore, the violations is 9C3 into 4. And therefore, this equation over here becomes 18C3 minus 9C3 into 4, which is equal to 18 into 17 into 16 by 6 minus 9 into 8 into 7 by 6 into 4. And on solving this, you will get your answer as 480, which is the answer to this question. In this video, let's discuss a special case with respect to grouping questions with an upper limit. If the maximum value permissible for each of these would have been less than the total, that is over here it is 15, then there is something to be kept in mind. For example, let's take the case where each of these have to be less than equal to 6 and the total is kept as 15. So 6 is less than 15 by 2, which is 7.5. Alright, in this type of a case, we cannot simply find the violations where one of them is given 7 and multiply that value with 4, right? It would not be 9C3, it would be giving 7 to W. If 7 is given to W, we will be left with 8 over here, right? 8 plus 7 is 15, so we'll be left with 8, and 8 given to W, X, Y and Z would be 11 factorial by 8 factorial into 3 factorial, which is 11C3. So in that case, we cannot simply do 18C3 minus 11C3 into 4. We cannot do this because there will be overlapping among violations. One case where a violation happens is when you give W7 is 7701, right? Because 7 plus 7 plus 0, 1 is equal to 15. But this same case will happen when you give 7 to X. Therefore, if you do 11C3 into 4 as the violations, this case over here will be double counted. So the number of violations in this type of a scenario has to be modified, that is reduced. And this is a time taking process and there is chance for getting an error. So it has to be approached with a lot of caution. In this video, let's do this question. W plus X plus Y plus Z is equal to 15 and W has to be less than or equal to 8, X has to be less than or equal to 9, Y has to be less than or equal to 10 and Z has to be less than or equal to 8. Pause the video, give it a try and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. Let me give W9 to violate this condition over here. I am left with 6. 15 minus 9 is 6. Therefore, I have 6 dots and 3 lines and this case can be violated in 9C3 ways, right? Similarly, in the case where X is given 10, the value 10, I am left with 5. Therefore, this can be violated in 8C3 ways, right? Because you have 5 dots and 3 lines. That's a total of 8 items. 5 are of one type and 3 are of one type. Similarly, let's give Y the value of 11 to violate this condition over here. I'm left with 4 items. So 4 dots and 3 lines, that's 7C3 ways of violating this condition over here. And if I want to violate Z less than or equal to 8, that would be the same as this one over here, which is equal to 9C3. Therefore, the answer to this question is the case where no upper limit is given, which is 18C3 minus the violations, which is 2 into 9C3 because you have one 9C3 over here and one 9C3 over here, minus 8C3 which is over here, minus 7C3, and this is your answer. Let's do this question. How many numbers less than 100,000 will add up to 16? So numbers less than 100,000 will have a maximum of 5 digits, right? Let me call them as A, B, C, D and E. Now it's mentioned that they need to add up to 16. That is A plus B plus C plus D plus E is equal to 16. And because A, B, C, D and E are digits, the maximum value that these can take is 9. Therefore, A, B, C, D and E has to be less than or equal to 9. So this is a clear grouping upper limit question. Now to violate this condition, let me give 10 to A and 16 minus 10 gives me 6. So I am left with 6 over here. And because I have to divide it into 5 groups, I need 4 lines. So 6 dots and 4 lines, that's a total of 10 items. So that can be done in 10 factorial by 6 factorial into 4 factorial ways, which is the same as 10C4. Therefore, the answer is the case where no upper limit is minus the violations. If no upper limit would have been there, I have 16 dots and 4 lines, that's 20C4, right? 20 factorial by 4 factorial into 16 factorial. Therefore, the answer is 20C4 minus 5 into 10C4, and that is your answer. Let's do this question. x plus y plus z has to be less than or equal to 9. How many whole number solutions can you form for this? Pause the video, give it a try, and then let's do it together. Alright, let's do it together. We need to find whole number solutions for this equation over here. X plus y plus z is equal to 9. It's an expression, right? Because it's not a perfect equality. Alright, we need to find whole number solutions to this expression. Now, for doing this one over here, let's introduce one more variable. That is x plus y plus z plus w is equal to 9. In this case, I am changing the less than or equal to into equal to. Let's try to understand how. If x plus y plus z is equal to 9, then the value of w will be 0. Similarly, if the value of x plus y plus z is equal to 8, the value of w will be 1 to make it equal to 9, right? And this can be 8 because this is mentioned is less than equal to 9 and 8 is less than equal to 9. And in this way, I keep doing this until x plus y plus z is equal to 0, and in that case w will be equal to 9. Alright, now over here, if you have x plus y plus z plus w is equal to 9, the number of whole number solutions for this equation we know is having 9 dots and 3 lines. That's a total of 12 items, 9 of which are of one type and 3 are of one type. Therefore, the answer would be 12C3, which is 12 factorial by 9 factorial into 3 factorial, right? That is the solution to this question over here. So we were able to solve this by converting this expression into an equation by introducing one more variable. Let's do this question. Mod x plus mod y plus mod z is equal to 10, and we need to find the integral solutions of this equation. Let me add that over here. We are trying to find the integral solutions of this equation. Alright, pause this video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Now, there can be 3 cases in this question, right? Now, before getting into that, remember what is mod of any number? What is mod of minus 2? It's equal to 2. What is mod of 2? That is also equal to 2. So it always gives you a positive value. Alright. Now, we said that there can be 3 cases for this equation. The first case is that none of x, y and z is equal to 0. That is, the minimum value is 1, right? Therefore, let's give 1 to x, y and z, and that gives 3 away, and we are left with 10 minus 3, which is equal to 7. Now 7 dots and 2 lines, because we have to divide it into 3 sets. So 7 dots and 2 lines, this can be distributed in 9C2 ways. We have seen that, right? 9C2 is 9 factorial by 2 factorial into 7 factorial. And it's not just 9C2, it's 9C2 into 8, right? Why is that so? This 8 over here is 2 into 2 into 2. That's because x can be positive or negative, y can be positive or negative, and z can be positive or negative. Whatever value you get when you do these 9C2 distributions, for example, one distribution can be 3, 3, 1 or 4, 3, 0, whatever. These 9C2 distributions, right? And in each of these, you can have a positive value or a negative value. And even in the case of 0, right? It's so because we have already distributed 1. So even if you do 3, 3, 1, it becomes 4, 4, 2, which adds up to 10. Similarly, 4, 3, 0, when you add 1, 1, 1 to each of these, it becomes 5, 4, 1. And we are taking a positive and negative value for each of this. For example, over here, this 4 could be positive 4 or negative 4. This 4 can be positive 4 or negative 4. This 2 can be positive 2 or negative 2. Because at the end, even if it's negative, we take mod and we get back a positive value. And when we add them, we will get 10, right? Therefore, each of these 9C2 distributions can have x, y and z either positive or negative. So the number of ways in which we can do this such that x, y, z is not equal to 0, that is none of x, y, z is equal to 0, is 9C2 into 8. Alright, let's move on. Let me make some space over here. The second possibility is one of them, that is one of x, y and z is 0. Now when one of them is 0, we can select any one among x, y and c in 3c1 ways, right? Selecting 1 from 3 is 3c1. So, and after that, after you do that, you are left with 2 more, right? And the remaining 2 can get 1 in 9c1 ways, right? What do I mean with that? That's, say I have taken any one as 0, I am left with 2. Let me just write, for example, x plus y is equal to 10. Now I'm giving 1 to each of these and I'm left with 8, right? Now 8 dots and 1 line, because I just need to divide it into 2 sets. That's a total of 9 items. 8 are of one type and 1 are of one type, and that is 9 factorial by 8 factorial into 1 factorial, which is 9c1. That's the 9c1 that I've written over here. Alright, let's move on. Now over here I have 3c1 ways of selecting 1 as 0, and the remaining can have 9c1 distributions. So that's 3c1 into 9c1 ways in which one of them is 0 and the remaining are such that when you take the mod and add, you get 10. Now remember, because it's mod, the remaining 2 can have each positive or negative values. Therefore, you need to multiply 3c1 into 9c1 with 4. This 4 is 2 into 2, right? This 4 over here is 2 into 2. Over here we had 8 because we had 2 into 2 into 2. Over here already 1 is 0 and we have to do positive and negative for the remaining 2. That's why 2 into 2, which is equal to 4. Alright, let me keep that aside. And the third case is when 2 are 0. So none are 0, 1 is 0 and 2 are 0. In this case, when 2 are 0, I can select the 2 in 3c2 ways. Alright, and if say x and y are 0, this over here has to be either positive 10 or negative 10, right? Then only the mod of that value will give me 10 over here. Therefore, there are just 2 possibilities, that's positive 10 and negative 10. So 3c2 into 2 is the number of ways in which I can fulfill this equation such that 2 of them have 0 as their value, right? And this 2 over here is positive 10 and negative 10. Alright, therefore the answer to this question is 9c2 into 8, which is what we got over here, plus 3c1 into 9c1 into 4 plus 3c2 into 2. And this is your answer to this question. In this video, let's discuss grid based questions. You have a grid over here, right? And you have point A over here and you have point B over here. Now say there is a person standing at point A and this person can only move towards the right and towards the top. Now the question is, in how many ways can he go from A to B? There are different ways, right? He could go this way, then this way and this way, and then he could go up and he goes from A to B. Another possibility could be he goes this way, then this way, then this way, this way, this way and this way. That's another possibility. So in a similar manner, there are multiple ways in which he can go from A to B such that he moves only towards the right and towards the top. Alright, let me keep this aside. Now, if he has to go from A to B only moving to the right and to the top, he has to move 3 times to the right and 4 times to the top, right? Let me denote moving to the right as H and moving to the top as V. So, he has to move 3 times H and he has to move 4 times V, right? Now, if you want to get the different ways in which he can go from A to B, the question becomes, in how many ways can you arrange 3 H's and 4 V's? Over here you have a total of 7 items, 3 are of one type and 4 are of one type. And we know that the number of arrangements in this type of a scenario is 4 plus 3 factorial divided by 3 factorial into 4 factorial, which is equal to 7 factorial by 3 factorial into 4 factorial. You can simplify this as 35. So in this question, the number of ways in which he can go from A to B such that he moves only towards the right and to the top is equal to 35. Let's do this question. There is a person at point A and he can only move to the right and to the top, and you have point A over here, point B over here, and point C over here. The question is, in how many ways can he go from A to B through C? Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Let's do it together. If he has to go from A to B through C, that's finding the number of ways in which he goes from A to C and from C to A, right? So he has to go from A to C and from C to B. So that's what we have to find over here. This is B over here. Alright, now if he has to go from A to C, he has to go 2 times to the right and 3 times to the top, right? So that's a total of 5 moves. 2 are of one type and 3 are of one type. And this can be done in 5 factorial by 2 factorial into 3 factorial ways. Now, to go from C to B, he has to move 4 times to the right and 2 times to the top. That's a total of 6 items. 4 are of one type and 2 are of one type. So this can be arranged in 6 factorial divided by 4 factorial into 2 factorial ways. And this is your answer. This can be simplified as 5 into 4 by 2 into 6 into 5 by 2, which is equal to 150 ways. So in this grid, if a person has to go from A to B, only moving towards the right and the top, and he has to go through C, he can do it in 150 ways. In this video, let's discuss a different type of question where you have to divide a given number of items into 2 groups. For example, you're given A plus B items and you need to divide them into 2 groups of A items and B items. Now, the number of ways in which you can do this is A plus B, C, A, right? Which is the number of ways of selecting A items from A plus B. Now, if you take out A items from A plus B items, you automatically get one group of A items and another group of B items, right? And this we know can be expanded as A plus B factorial by A factorial into B factorial. Remember, instead of A plus B C A, we could have also written it as A plus B C B, and that also will give us the same answer over here. Remember, over here A plus B is equal to what we have over here. That's the same property which we used when we said 7C2 is equal to 7C5. Alright, let's move on. Say we are given a condition where A is equal to B. Alright, let me write that over here. If A is equal to B and you want to divide 2A items into 2 groups of A items and A items, as per this formula over here and what we have seen over here, it can be done in 2A factorial by A factorial into A factorial ways. Now, this is true if you can differentiate the groups from outside. Let's try to understand what we mean with that. Now, there are 2 possibilities. One is this possibility over here, and the second possibility is you cannot differentiate the 2 groups from outside. If you cannot differentiate the 2 groups from outside, for example, you are splitting 2 items. For example, you have A, B, C, D, and you are converting them into groups of 2. So if you do this part over here, one group that you get will be AB and CD, and another group will be CD and AB. Now, over here, this is fine to count these as separate cases if you can differentiate it. Like, for example, if you have room 1 over here and room 2 over here. In this case, these 2 are different. But if you cannot differentiate these 2 groups from the outside, you need to divide this by 2 factorial. That is 2A factorial divided by A factorial into A factorial into 2 factorial over here. Let's try to understand this in a better manner. Let's move this aside. Alright, now say you have 4 friends A, B, C and D, and you need to make groups of 2 from these 4 people. Now, what are the different ways in which you can do that? You can do it in 4C2 ways, right? Which is the number of ways in which you can select 2 items out of 4 items. What is 4C2? That's 4 into 3 by 2, which is equal to 6. Alright, let's write the 6 possibilities over here manually. Alright, so these are our 6 possibilities. That's 1, 2, 3, 4, 5 and 6. Alright, and we try to make groups of 2 over here. Now you can see that number 1 and number 4 are actually the same, right? Having A, B and CD together and CD and AB in this manner is not different. It is the same unless you are able to differentiate it from the outside. So in the case that you just need to divide them into groups of 2 and make them stand together, there is no way from the outside to differentiate them. So the answer is not 4C2, it's actually 4C2 by 2 factorial, which gives us 3, right? That's because you cannot differentiate this one over here and this one over here. And 4C2 by 2 factorial will give you the answer as 3. And that's 1 over here, 2 over here and 3 over here. And these 3 are actually repetitions. So there are just 3 ways in which you can divide 4 friends into 2 groups where each group has 2 friends. Now, if you group them in this manner and allocate them to room 1 and room 2, in that case, having AB and CD in this manner and AB and CD in this manner is different, because from the outside you can differentiate them, and in this case you do not need to divide by 2 factorial. So over here the ways in which you can do this would be 4C2, which is 6, which is the what we have written manually over here. Let's continue understanding grouping of items. Say you have M plus M plus M items. That's you have 3M items. Alright. And you need to group these into 3 groups, each of M. In how many ways can you do that? Now again, over here also you have 2 cases. If you can differentiate it from the outside, that would be 3M factorial by M factorial into M factorial into M factorial. And if you cannot differentiate it from the outside, that would be 3M factorial by M factorial into M factorial into M factorial divided by 3 factorial. Now how did we get this over here? Let's take a quick side note. That would be the number of ways in which you select M items from 3M items. That's 3MCM, and then you are left with only 2M items, right? Now again, out of the 2M items, you need to select M items. So 3MCM into 2MCM will give you 3M factorial by M factorial into M factorial into M factorial, right? What is 3MCM? That's 3M factorial by 2M factorial into M factorial. And what is 2MCM? That's 2M factorial by M factorial into M factorial, right? And these two gets cancelled and you're left with 3M factorial by M factorial into M factorial into M factorial, which is what we have over here. The only thing you need to keep in mind is if you cannot differentiate from the outside, you need to divide this by 3 factorial, which the logic is the same as to why we divided it with 2 factorial in the case where we divided 4 friends into 2 groups of 2 each. Let's do this question. In how many ways can 79380 be written as the product of 2 numbers which are co-prime? Pause the video, give it a try, and then let's do it together. Alright, I hope you have given it a try. Let's do it together. Remember, 2 numbers are co-prime if the highest common factor of those 2 numbers is equal to 1. For example, 12 and say 13. These 2 are co-prime, right? Because there is no common factor except 1 among these 2 numbers. Alright, now over here we need to write 79380 as the product of 2 numbers that are co-prime. We start with prime factorizing 79380. Alright, so prime factorizing 79380 gives us 7 square into 3 to the power 4 into 2 square into 5. Alright, now remember, co-prime are numbers that have only 1 as a common factor. Alright, now to understand this in a better manner, check the section where we discuss numbers. Let's move on. Now over here I have 7 square. Let me call 7 square as A. Similarly, 3 to the power 4 as B, 2 square as C, and 5 as D. Now, why is it that I'm grouping them together? Because I need to divide these into sets of two numbers, right? I need to form two numbers with these such that they are co-prime. So I cannot give 1 7 to this number and 1 7 to this number, because if I do that, they would no longer be co-prime, because 7 would be a factor over here and a factor over here. Therefore, if I give any 1 7 to this number, I have to give both together. That is, I can allocate only 7s together, I can allocate only 3s together, I can allocate only 2s together, and I can allocate only 5s together. Alright, let's move on. So after having grouped them together, all we need to do is divide A, B, C and D into two groups, right? We just need to divide it into two groups, and one group will be one number and the other group will be the other number. And because we are taking all of these together, if you multiply them, definitely you will get back your number with which we started off. Alright, now let's try to divide A, B, C and D into two groups. There are three ways in which we can do that, right? I could put all these four into one group and have nothing in the other group. That's four items over here and nothing in the other group. The other way is I can put any three of these into one group and whatever remains into the other group. And the third way of doing it is I split it evenly. That is, two of these are put in one group and two of these are put in the other group. There is no other way in which you can do this, right? If you are writing it as 1 and 3, that's a repetition of what we have over here. So we don't write that over here. So there are these three ways in which we can divide A, B, C and D into two groups. Now, in how many ways can we do this one over here? 4 and 0. We can do it in only one way, right? What is that one way? That's A, B, C and D together in one group. That's multiplied with nothing, which is 1, right? Because 1 is a factor of every number. So writing 79380 as 1 into 79380 is this possibility, which is only one possibility. Alright, in how many ways can we divide A, B, C, D into 3 and 1? So that can be done only in 4C1 ways, right? Because this one over here can be either A, or it can be either B, or it can be C, or it can be D. So there are just four possibilities, right? So whatever comes over here, the other three automatically forms this group. So I can do this type of a distribution in 4C1 ways, which is equal to 4. You can note that I could also have taken 4C3. That also is equal to 4C1, which is equal to 4. Now, over here, I need to divide them into groups of 2. And in how many ways can I do that? I can do it, as we discussed, in 4C2 by 2 factorial ways. And I have to divide by 2 factorial because from the outside I cannot differentiate the 2, right? Because I'm not allocating it into something recognizable, like we discussed in the problem where we divided the friends and allocated them to rooms. But over here we are not doing that. So there is no way to differentiate it. So for example, in one case I might write it as A into B as one group and C into D as the other group. Now this, and writing C into D as one group and A into B as the other group is one and the same. That's why we have to divide with 2 factorial. And this over here gives us 3. Alright, let me make some space over here. That's the same thing, right? A into B into C into D is the same as C into D into A into B. Alright, let's move on. So what is the answer to this question? You can do it in 1 plus 4 plus 3 ways, which is equal to 8, and that is your answer. Let's do this question. In how many ways can the given number be written as the product of two numbers which are co-prime? So already the prime factorized way of the number is given. Pause the video, give it a try, and then let's do it together. Alright, we are back. I hope you have given it a try. Over here, this is A, 3 square is B, 5 cube is C, 7 to the power 4 is D, and 11 square is E. So you have 5 items, right? And in how many ways can you divide them into groups of 2? You could have 5 and 0, right? Or you can have 4 and 1. You can have 3 and 2. And is there any other way? You can have 2 and 3, but that would be a repetition of what you have over here. And so these are just the 3 ways in which this can be done. 5 and 0 can be done only in one way, right? Because you have to put everything in one group and the other group will just have 1. So that's equal to writing A into B into C into D into E into 1. So that can be done only in one way. What about 4 and 1? You can select this one in 5 ways, that is 5C1 ways. So that's equal to 5. So dividing these into groups of 4 and 1 can be done only in 5 ways. What about 3 and 2? You just need to select 2, right, out of these 5. That's 5C2 ways of doing it. 5C2 is equal to 5 into 4 by 2, which gives you 10. So the answer to this question is you can do it in 1 plus 5 plus 10, which is equal to 16 ways.